Here I go. Let's get started. So perfect square trinomial, we're not going to do anything different than we've already done. But we can write our final answer differently. So if I want to, this is a perfect square, and how do I know it's a perfect square? Well, we know it's a perfect square mostly because of the outcome. Okay, so let's factor this guy. The coefficient of the a squared is, sorry, we are in lesson 7, which is on page 365. My apologies. Okay, so when you actually factor this, we're going to get 1 and 1. What are the numbers are we going to try for 4? You could try 1 and 4. You could try 2 and 2. Let's try 2 and 2. Will the diagonals add to 4 when we multiply them? Yeah, so the factored form here is a plus 2 times a plus 2. So that's what we call a perfect square. Why is it a perfect square? Because they're both the same, right? So you could also write this as a plus 2 squared. Exactly. Okay. Now let's try doing the next one. C, sorry. I'm actually going to zoom in. It's hard to read that. Okay, so let's look at C. 4x squared minus 30x plus 81. Okay. Now there is a shortcut to knowing that this is actually a perfect square. Is it? Okay, let's try this. So square root of 4, 2 and 2, 9 and 9. What would be the sign on the 9? Both of them would have to be negative because we want to add to negative 36. So negative 18 would be this diagonal, negative 18, and that adds to negative 36. Okay. Okay, so what would be the factored form? And then squared. Yeah, we don't have to write it twice. We could just write the power of 2. Okay. So if we know, if I go down to A, so what if I knew it says this was a perfect square? I'm told it is a perfect square trinomial. What would the middle term have to be? Well, how would we figure that out? Okay, so if it was a perfect square, what would be the two numbers here? 2a. So if this was a perfect square, what would be my two numbers below 1? 1 and 1. What would have to be the two numbers if we're under 100? 10 and 10. Okay, so what would be the middle term then? 20. 1 times 10 plus 1 times 10 be 20 what? 20x. Good. You could have also had, because they didn't tell us the sign, well, this one was plus, this one's minus. What would it be here? Guys, the 10s would both be negative, so the sum inside would be negative 20x. If I knew this was a perfect square trinomial then, what would be my two numbers? 5 and 5. 36 would be 6 and 6. So what would be the middle term? No. Okay, so 5 times 6 is 30. 5 times 6 is 30. So 60x. Good. Okay, the last one, if it was this is a little different. We know the middle term, but we don't know the last. Now we know the first. What would the two numbers be? 3 and 3. So if it's a perfect square, we know those two numbers are the same. And what do the diagonals what would they have to multiply to? Individually, each one would have to be a 12 and a 12 to add to 24, because they have to be the same thing. So 4 and 4, meaning that this was 16. Okay, so divided by, okay, so let's go back. Let's look at that one again. I know that I want my sum to be 24, right? So we know that our sum of the two diagonals is going to be 24. And we know that because it's a perfect square, the products, these two have to be identical. So what two numbers, when they're the same, added together equal 24? Has to be 12 and 12. And so then working backwards, 3 times what is 12? 4. 3 times what is 12 is 4. And then that means that our last number had to have been 16, because 4 times 4 is 16. Okay? Crazy? Okay. Try A on your own. Okay. Try A. Okay. So here, what did you get? 7 and 7 and 1 and 1. And what are the signs on the 1? Minus. Both minus. So 7x minus 1 times 7x minus 1. You could have also wrote it as? Good. 7x minus 1 squared. C, if you have a fraction, okay, we want to factor the fraction out. Do you remember doing this? Sort of. So I want a common denominator, everyone to be over 9. Remember this? We did it before the break. Factoring with fractions. Okay, so then I have 1 over 9a squared minus, what would that fraction be? 2 over 1 if I want it now over 9. 18 over 9 is the same thing as 2 over 1. Plus, now I want this over 9 instead of 1. 81 over 9 is the same thing as 9. Okay. Now I can factor out the 1/9. So factoring out 1/9, what's left over inside the brackets? A squared, we're basically pulling out the denominator. Minus 18ab plus 81b squared. So now let's factor that trinomial. Yeah, we did this. It's been a while. Okay, so we're factoring out the denominator. We pull out 1/9. Because out of the numerators, if we look at the numerators, 1, 18, and 81, what can you factor out? Just 1. Out of the numerators, 1, 18, and 81, just 1 because of the 1. Now looking at the denominators, 9, 9, and 9, I can factor out the 9, the 1/9. Okay, so 1 from the numerator, 9 from the denominator, and so we're left with just the numerators. So we factor that 9 out. Okay, a squared, 1 and 1, 81, 9 and 9, and their signs are going to be both negative. So the final factored form is 1/9 times 1 what? A, and then you can write it twice or you can write power of 2. Okay, turn the page. No, let's look at number 4. All right, example 4. Sorry, did I say lesson 4? Oops, sorry. This shouldn't be much different, right? We just do one of these, pick one, A, B, or C. Okay, it is. Okay, so when we multiply, we still treat it the same way, right? 1 and 1. The 14 becomes? Well, it's not going to be a perfect square, is it? No. What two numbers? 7 and negative 2. Okay, so which one has to be negative? We want to add to a -5. -7, +2. Would that add to -5 when you multiply diagonals? Yeah. Okay, so instead of just a and a, what's going to be the variable for each one? A squared and a squared. So this factors to a squared -7 and a squared +2. Okay. Now b we're going to come back to. Yeah, the second part of our lesson today. Let's see here. Let's look at number 5. I'd like you to try a. Okay, you try. 5a. Difference of squares is a lot easier to factor. It's very easy, but it sometimes, what's special about them is difference of squares occur when we have a binomial. Okay, you need a binomial. You need both terms are perfect squares. And one of the terms is positive and one's negative. One positive and one negative. Those are the three conditions you need for a difference of squares. So an example so you know what I'm talking about, 9x squared minus 4 is an example of a difference of squares. It's something that actually we can factor that. Are both terms perfect squares? 9x squared, is that a perfect square? Yeah, the variable has to be an even power. And then 4, is that a perfect square? Yeah, ignoring the sign. One of them has a positive, one's negative. Yeah, so if those three conditions are met, it actually is factorable. It's called a difference of squares, and it's a lot of fun to factor these. It's like a trinomial where the middle term is what? 0. The middle term is 0. So if I wanted to, I could rewrite x squared minus 9 as x squared plus 0x minus 9. Are those not the same thing? It's really small. Let's zoom in. You're just going to agree? Okay, so yeah. Okay, so if I wanted to factor x squared plus 0x minus 9, what are my two numbers for the x squared? 1 and 1. Multiply to the 1. Okay, to multiply to 9, but we want to sum to a 0. How are we going to do that? Multiply to -9, but sum to 0. Guys, can you please stop it? 3 and -3. Would you agree that multiplies to -9? And add the diagonals add to 0. Yeah, so what's the factored form then? X plus 3 and x minus 3. Cool. So it's like a perfect square, except for what?
Not perfect.
It's not perfect because?
Negative and positive.
One is a positive, one's a negative. So it's like a perfect square, except for their opposite signs. Why? This is why the middle term cancels out. You get the exact same middle term, but one positive, one negative. When you add those together, you get 0. So this one, when you factor, there's a shortcut. When we factor difference of squares, well, x squared, the two numbers are 1 and 1, right? 1x, 1x. 49 would be 7 and 7. One of them has to be negative, one of them is positive. Done.
Wait, is that it? So we don't have to write everything you wrote over there, we can just do that?
We can go straight to factoring.
So we don't have to do the down?
No, no. You can. You are welcome to. You have to put in that 0, right? But it's a lot easier if we can go straight to, yeah, factored form.
Wait, does it matter which one goes first?
No, it doesn't matter the order. So you could have wrote x minus 7, then x plus 7.
Hey, that's the easiest question I've ever done.
Difference of squares are the easiest to factor, yes. You just go straight to factor. Okay, so what would this be? X Minus 6x plus 6. Doesn't matter if the plus is first or second. Okay, what's the next one? X plus 1 and x minus 1. So we square root each term and then put a plus and a minus. So this one would be?
A plus 10. A. Oh.
And A?
A minus 10.
A minus 10. Done.
Oh, I'm not paying attention.
All right. So please turn the page.
Hey, much easier.
Okay. So, can you please do all of number 1 really quickly? Well, as fast as you can.
Yeah.
Okay, well then I'm done.
Of course I know.
Difference of squares are fun. No? You just got to be able to square root. Okay, so let's make it more interesting, because that's too easy, right?
No. It's hard.
So notice that this last line here is very important. Note that it is not possible to factor a sum of squares, x squared plus 4, or x squared plus 0x plus 4. Remember I said one sign has to be positive, one is negative. Usually the negative's in the center, separated between the two terms. Okay? The reason why that's not factorable, there is no possible way to factor this so that the middle term cancels. Because if the middle term cancels, they have to be opposite signs. If they're opposite signs, that means our product here has to be a negative. Okay? So this is not factorable. 1 and 1, 2 and 2, is there any way to make 0? Or if I do negative 2 and negative 2? No. Not factorable. Yeah?
So, we got like question on a test and it had that. Just say we just put not like.
You just say not factorable. Or write the same thing down. You're done. You could. Yeah. Yeah. All right. So what happens if we have higher powers? Okay. Why don't you try B and E before we do that? B and E. I'm going to try and finish this lesson in a timely manner.
Do we have one lesson?
And then we're done. This is it. Yeah. It's not so bad, hey? It's not like a double lesson. Yeah. B and E. You done? Ooh, maybe and F. B, E, and F. I like F. I know. Shh, guys. Jackson, did you finish? Good. What'd you get for B?
I 9A plus 1
Okay.
and 9A minus 1.
Beautiful. What did you get for E, Nadir?
What's the one? X minus 5.
Nope.
Oh, what? Oh, oh,
Same thing you asked, right? That's why I asked you. Because they're both positive. Remember, one has to be positive, one is negative. Okay, pardon me?
Oh wait, so I just like basically.
Wait, so is it completely not practical?
Yeah, completely non-factorable.
I did that.
Nope, it's not factorable. There's no GCF. There's like, nope, wrong. Okay. So rude, hey? So the last one, what would it be?
8 plus 3AB, 8 minus 3AB.
8 minus 3AB and 8 plus 3AB. Your variables could be. You probably wouldn't. You like to. It's always good to keep the minus in between. So if you have a question, like say I gave you this negative y squared plus 100, that is factorable, guys. Shh. So this is a difference of squares. Can you square root both of those? Yes. Is one positive, one negative? Yeah, just rewrite it, rearrange it. So I would rearrange it to this 100 minus y squared. Those are the same thing. It's always nicer when the minus is in the middle. It's better because otherwise you get negative y plus 10 and positive y plus 10. And that's really ugly. So just rewrite it so that the minus sign is in the middle if it's not given that way.
Technically still right?
Yes, it is. Still right if you wrote it the other way. All right, now let's make it fun.
That'd be hard. I'll go right.
Okay, almost. We're going to do 2a or 4a on 350, and then we're going to go back. Remember I said we're going to come back to this question on lesson 7. Okay? Okay, so 2a, what would I do first? Really quickly. What would I do first? Is that a GCF? Is that a difference of squares right now? Can you square root 2? No. But what can we do? Greatest common factor. If we can pull out a common factor, we must. Now that I pulled out a common factor, Charlie, you're with us? Okay. Now that I pulled out a common factor, is it now a difference of squares? Yes. So it factors to a minus 5 and a plus 5. Okay, so please turn back to lesson 7 now where we said we're going to come back. Remember I said come back to? We're going to come back to this one. That was on page 366. Okay. So there's a trinomial, so we're going to just use the usual trinomial method, 1 and 1. What numbers are we going to use here? 5 and 1. Okay. Now, which one's positive, which one's negative? The one is negative, yeah, because we want to add to a positive 4. So writing the factored form, what does it look like? X squared plus 5 and x squared minus 1. What do you see here? Is there anything special in one of those brackets? This guy. What is he called? Difference of squares. Number 4B. Are there really?
Yeah, including the no fears.
Wow, that's creepy. Okay, so what does x squared minus 1 factor to, ladies and gents? X plus 1 and? There you go. So this factors further into those two. Oh, yes, you do. It's not fully factored until it's fully factored. Okay, so the reason why...
So that's another step that we have to make sure we don't miss.
No, we're still not done. Okay, go back to question 5. Yeah, lesson 5. Or sorry, lesson 7. Lesson 7. Sorry. I'm sorry. I meant class example 5. I know. But then remember we're going to have more time next block, okay? I'd like to look at one of these. Let's do number 6 here. Can you do number 6? Okay? First question, is there a GCF? We always ask that first. No. Now that there's no GCF, it's a trinomial. We're going to use what method? The Chinese. Okay, so 8. Let's try 2 and 4. 3? Okay, let's try 1 and 3. Does that work? Why doesn't that work? Does it?
Yeah, it does.
Why doesn't it? It looks like it does. Because of the negative. One has to be positive, one negative. So that's not going to work. So let's try switching them. Yeah? Oh, yeah. Oh, I'm sorry. It's me. I can't. Things just fall through my fingers. Okay. So does that work? 2 and 12. Negative 1. Beautiful. Okay. What is it factor 2 then? 2x squared plus 3 minus 1. Are we done? I know to check because of the x squared. Is one of those a difference of squares? The second one, what is it factor 2? 2x minus 1, 2x plus 1. We're done. Okay. Can we check your, yes, and could you check your work? Yeah, you could test it in your calculator, right? Okay. Are we done? Can we do just one more?
We get it, I promise.
No, let's do, turn the page to 8. Don't. I love you all. Okay. Let's just go through B and then we'll call it. I promise is the last one. Okay? No lies. Promise.
What page is this?
We are on page 368. Number 8B.
Are we ever going to use this in real life?
Yes, all the time. Okay?
That's a lie. Hey, I'm going to be watching.
I never lie. Okay, so first step. I'm trying to go through this quickly. Marcus, what do I do first?
For that one?
Yeah?
Oh, I don't.
Gave you a hint already there.
Okay, so we do the, what's it called?
It's a binomial.
Yeah, you have to do GCF.
Good, GCF. That's always the first thing we check, right?
It's a 5.
5, and we're left with, what is 80 divided by 5? It's okay. 16, I don't blame you. Okay, now, I see what that puts off some alarm bells. What is putting alarm bells in my head? Can you further factor that? I see an x to the 4th. That's an even power, so that could be broken down possibly. And then I see a 16. Hey, oh my. And then I see that there's 1 positive, 1 negative. So what does that factor to? 4 and 4?
4 plus x squared.
Plus x squared and
Minus
x squared. Again, alarm bells go off in my head. I see it's not, I still have an even power, so I need to check. Which one can I do again? The negative one. So that can factor to what? It's like Inception, but backwards. Okay.